Hey guys, this is a follow-up of the previous video in which we discussed atomics regarding Rust. However, we will be discussing fences in this case. Okay, so um, let's just get started. What happens is there's this thing called a memory fence, and what happens is it can in fact replace these atomic stores over here, right? As well as these atomic loads. And the question is, why would you want to use it? Well, you'll notice that we're doing the memory ordering as well as the atomic operations in one go, but we could actually separate them out. And we do this with fences. So I'm going to show you how to do it now. Right. So we're going to take a fence. It just came up there. Fence. And as you can see, it's in the standard async atomic fence crate. And we're going to take this release over here, we're going to put it in there. And then we're going to make this thing relaxed. Right? So what we've done is we've taken now the release from the atomic store, where we put 3 into it with release ordering. And we have the release is now inside of the fence, okay? So this is equivalent to what we had before. Where we had the release inside of our atomic store of value 3, right? And we could do something similar here, where we could have a fence, and then we could say this one should be acquire. So it will be acquire, and this one could be relaxed. Right? So now we have separated again our atomic operations, and we have separated our memory orderings. Right? And let's see if the values are exactly the same. Where in fact we know that it's not 1, it's not 2, but 3 for x. Right? By the way, you would probably have to go and check the other video prior to this, because it will help you understand what we've done here. But effectively, we have a memory ordering with the value 3, right, over here, being added to our atomic variable from the main thread, right? And then our underscore t thread, in fact, as happens before relationship, so that it can read and load this value after it has been stored. So we expect x to be 3 in this case, and if we run it, we have it to be exactly the same, because the meaning is exactly the same. All we've done is to separate out this atomic and memory ordering. Now, you would use this, right? Let's assume you had some sort of value. Let's copy it here. Let's call it P. And now we can say in between it. So now we're essentially using memory ordering over multiple operations. That's really the point. So now we could say, well, it starts out at, I don't know, it started out at like 5, right? And then we could put, let's say, put 1 into it now, and it's going to be right? So effectively what we're saying is that we're operating over both A and B within the space called with the memory fence above it, and our operations will go below. And it must be in this order, by the way. So what happens is we can now say, oh yeah, we can just make another variable. We can call this one y, and we can say it's b, and now we can print out b. By the way, you shouldn't copy and paste it. And now b most probably will be instead 3. Let's check that. Yeah. So you see what we've done is we've effectively said, okay, let's increase we're going to separate our memory ordering and our operations, and use the same memory ordering over a larger scope of values, essentially. And that's how we can use fences instead of using the memory ordering inside of our atomic operations. And again, I'm going to recommend that you think more a little bit about this thing, but also that you perhaps try out a software that I don't worry, I'm not getting anything from talking about the software, but really just something that I really enjoy speaking about is TLAPlus and Pluscal, and it allows you to model your software so that you can coordinate your processes so that they don't have data races or race conditions, all these different things that we're talking about. And it makes your Rust code and your Rust concurrency safe. And by the way, this applies to any software. So it could be Java or Go, or whatever. And you can just go download it. It's free software, actually. So yeah, please go and get it. And thanks for your time. And again, I hope that this was helpful. If you like it, please like and subscribe. And I'll be making more of these videos. So please come back soon.